Welcome to Study Loop.
Hello, let's talk about this optics question. We're talking about a man who's got a pair of glasses that have a focal length of 50 centimeters. So 50 centimeters focal length, and he works at an office, and he realizes that to read something clearly, he has to hold that material 25 centimeters away from his eyes. Now, essentially, this problem is trying to talk about how vision deteriorates over age, because the problem also says after 5 years, plus 5 years, the man notices that now he has to place with the same glasses, he has to place material 40 centimeters away from his eyes to notice or to read the material clearly. So we've been asked to find a new focal length f prime such that the new glasses would allow him to go back to his old reading distance of 25 centimeters. And we're going to try and solve this in two parts. Okay, so we're going to do this in two parts. So starting with part 1. We wish to figure out in part 1 something called his near point. That is where his eye will be forming the image from placing the material 40 centimeters away from his eyes. So we're going to use the formula 1 over f equals 1 over dO plus 1 over di. Here, di is essentially his near point, because based on where you place the object, the image is being formed at his near point. So that is 40 centimeters, and that is thus 50 centimeters. So essentially, what you want to do is do this following operation. 1 over f equals, you're gonna plug in the numbers. So 1 over d sub np equals 1 over 50 minus 1 over 40. Now once you put that into a calculator and you find whatever value you're supposed to get for dnp, you should get d sub np equals negative 200 centimeters. Now, it's easy to get scared by looking at that number. 200 centimeters is pretty huge for, that object. But then again, remember, that's just where his eyes are forming the image. That's not exactly what we want just yet. What we want is a new focal length, again, f prime, that will allow him to form an image at his near point, but only by holding his material 25 centimeters away from his eyes instead. So we're going to do that in part 2 of this problem. So part 2. So in part 2, we want to do something very similar to part 1, but instead now we're looking for f prime, the focal length of the new glasses that he needs. We're using essentially the same formula, but we're modifying di to be dnp. So 1 over f prime plus 1 over do is now 1 over f prime equals now 1 over do plus 1 over d, you guessed it, dnp. Now here, it's really important to note that we must enter the negative sign along with the other signs in our calculation. So this will actually be the full negative 200 centimeters. And DO will now be his old distance of 25 centimeters. So now if we do the same kind of math again, so we do 1 over f prime is equal to 1 over 25 minus 1 over 200. And then we compute, once we're done with all the algebra and stuff, we compute it, we get f prime is equal to 28.6 centimeters approximately, which is, again, approximately equal to 0.29 meters. Now, the subtlety here is that negative sign right there is actually coming from the negative sign in the near point. And the negative sign in the near point is coming because of our sign conventions, where if an image is formed in front of a lens, it's considered technically to be a negative distance away from the eye, and also the image is virtual. But the answer to our question is 0.29 meters. That's the focal length that we found at the very end. So he needs a new pair of glasses with a focal length of 0.29 meters for him to be able to clearly read his material from a distance of 25 centimeters again. And thank you for watching.